All right, let me continue to say a few things about. In fact, this is our kind of our review from yesterday too. This is the stuff we talked about. Let me get my clicker. And we're still on a mission to talk about the definite integral, and we still haven't really come around to any formal way of doing this, and you haven't really still seen the benefit of using these rectangular approximation methods. So we introduced this idea, though, yesterday, and we said that one of the useful reasons for having this kind of approximation technique is that it's systematic. And we can, for example, teach a computer to do it. That's one benefit. And so I need to show you how to use that program if you haven't figured it out yourself. Did most of you figure out by how to do it by yourself? It is pretty straightforward, but I'll show you how to do it here. All right, we did all this yesterday, right? Okay. Where did we get to? Yes. I'll run through how to use the program in a second here. All right, so I think we got to here. All right, so I'll get to the program in a second. Of course, what did we see even as we were doing 8 subintervals on this example yesterday? And I think you probably didn't even bother to write these down because you're like, okay, I get the idea. And the realization we made was that this is like better, like more is better. Is like the realization we came to. Another advantage of systematizing this. And in fact, you might think, well, maybe I could get arbitrarily close to the exact value of the area under the curve by using this more is better idea. So like, what's better than 8 rectangles?
800.
800 is better. What's better than 800?
8 million.
Well, of course, where are we going with this? And what's the centerpiece of our calculus course?
Infinity.
The limit, right? Don't we care about approaching infinity? Now, there are 2 limits that work here. Of course, there's the number of rectangles, which we would love to be infinite. And that is, in fact, what we'd like to do. It's not just like pie in the sky. That's exactly where we're headed. And then the other thing that's happening, too, is there's another kind of limit happening here. What's happening to the width of the rectangles, too? Yeah, they're headed to, if you have an infinite number of them, the width of those rectangles is headed to 0. So let's keep that in mind as we think about this expression. So I think what we're asking us to do is just to stick a limit in front of that, right? So I think I put this up there. I said the approximate area, the area is approximately, I used an approximately equal to, and I said that, right? For any given n, we get an approximation. But if we let the limit go, the limit as n goes to infinity of that thing happen, and we actually do get the exact area under the curve. Using, again, like I said, the thing that ties, even though these are disparate ideas, it seems like derivatives and integrals seem different, they are tied together by this, at the very least, this notion, this idea of the limit. So we are using limits to govern our idea. I stole this animated GIF from online somewhere. There it is. More and more rectangles. More. And you can find not just this program we're using right now in the calculator that we'll show you how to use. Yeah, we can just watch that over and over again. But you can find lots of tools online too. You can just like Google like rectangular approximation or sometimes you might have to, or Riemann sum or something like that, and you can find a million Java applets out there that'll do this or whatever. So yeah. Good. So on your calculator, here are the instructions I'll give you. So try, let's actually try the one we were just doing. So could everyone, just to verify you get the same number I got here, 6.65624. Let's see if we get the same answer. We'll run MRAM 8 on our calculator with this guy right here, okay? So enter this into, if you have, hopefully you all have the program. Enter this into Y1, and let's make sure we all get the same answer. 1/8 x squared, I guess, on your calculator, plus 1. And then, so 1/8 x squared plus 1 is the equation.
Okay.
You need the program again?
The first one, which one
Huh?
Wait, which one are we doing? Yeah, which equation?
If we're going to try and match the one we were just doing, Then let's do midpoint rectangular approximation. Adjust beforehand if you want to get a good view of it. It's actually not super important, but if you want to get a good view of it, do that before you run the program and get a good view of the interval. What was the interval?
0.
I think it was still 0 to 4, right? Over the first 4 seconds. Okay. So 0 to 4, make sure you get a good window on it, just in case you want to see it. And then now you can run numin, enter the lower limit 0, and then the upper limit 4. Choose midpoint. For subintervals, choose 8 if we're doing 8 rectangles. We'd like that. And then once you do it, it'll show you the picture, which is pretty, and it should be similar to the picture I drew for you. After you see the picture, that's actually kind of somewhat cosmetic, right? Who cares about the picture? What we really want, press enter. It should be like pause right then. Dot, 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 dot. Press enter, and it should also give you the actual area. And see if you got what we got, 6.65624 approximately. Help each other out. I can try here too. I think someone was able to get that for you. Yeah, and these should overcome to any of their calculus through the top. Did you get the same value? Help the person next to you. Let me see if I have this on my calculator.
I'm gonna do with 800.
Cool, yeah. I'll do it on the screen too here. I assume you guys are figuring it out there, but yeah, careful. Don't just go like do 500. We'll see you in 20 minutes. Not 20, maybe 5 minutes though, right? It takes a while. I'm not gonna try 800. Yeah, and did anyone do more than 8 and have it finished? Did you get it? You'd probably get a better estimate than I did then. I mean, that's already not bad. I'll just tell you right now, the actual value is 6 2/3. So how close are we getting? Did you do 100? What'd you do? Here, 1 second. Zoom. Or Zoom fit. So here, I'll run through it with you guys again here. It's, yeah, here are the instructions. Where'd my calculator go? All right, so run numin. Again, I have my nice picture already set up. I set my window up. I'm good to go. Lower limit 0, upper limit 4, midpoint 8. Let it do its thing. Dot, 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 press enter. And it should give you the same thing I got up here too, right? It finished finally? So we got 6.666. Okay, so it is very, with 800 rectangles, you're getting just whatever that is, 5 decimal places, you are getting 6 2/3. That's, wow, good. Yeah, did you do 800 as well? Okay. And it allows you to do it again. If you hit 0, it takes you back to the previous menu. If you enter that for the number of subintervals, and then if you hit 5, you can quit. You can also quit. It's a basic program. You can always hit second mode and quit anytime too. So, all right. Any other questions about how to run the program? Even though we haven't even studied trapezoidal, you can already run it and see what it looks like if you like. Somebody help Rebecca out. Okay. We're good? All right, more practice. Here we go. More practice with the program. All right, so on this new example, x squared plus 2, I'd like to watch this converge from below and above, hopefully, right? I'd like to get some over and under estimates. I'd like to see how these behave side by side. All right, ladies, LRAM, men, MRAM, right? Come on, L, you know what you. And RRAM is for everyone. Everyone. I don't know. So everyone do this one. And in a minute, maybe you guys can split up the work here. You know, someone at your table start on 100. I want to get all these values here, though. You can split up the work. I don't need.
I'll do every. Oh, I just maybe said
Yeah, you do have to start receiving first.
Oh, right.
Have it be waiting and then hit transmit.
why did you put 1,000? Hey, whenever like you're grabbing something, you want to stop.
Alrighty, my area 81.66568.
Oh wait, what did you say?
It's.
You lost it.
I didn't realize.
You're never gonna get it back.
Yeah.
Simply toward yourself. Got it?
I don't even have any packages coming. I already got one.
It wasn't like this. You get it?
X.
Oh, the wrong one.
Are they like stocks for
Yes.
Okay, let's get these filled in here.
Wait, 1, 6. Which one do you do?
Mr. Chase,
Yeah.
are we qualified to use this program
Are we
on the AP test?
You won't need to. I'll tell you why soon enough in your life.
Can you archive it?
You can't. I'm going to tell you soon. You won't need it. It's mostly instructional. We'll see that. Belinda, can you fill out the ladies column? And Matt, can you fill out
I'll do
the men's column? Oh. All right. Tap one of these guys. Tell them to do it. 0? Oh, yeah, you can do that. See what you want for him. Or what? Stop showing. Okay.
Whoa!
That's good. Yes.
All right, here, let's get
Something to see the amount of interviews.
good Jennifer.
So interval 1 to put in.
You want to do the Oh, you want to do the men's?
I got 81.59.
Did I not?
Huh?
Yeah, I do a website. Wait, how did you say to go back to like?
And maybe you want to do the everyone column?
Everyone.
Everyone.
How do you go back to the
0.
That is too much. That's okay. I didn't get Oh, you say traffic inside. I know, but we have to say about it. Now we're late. What? Are you challenging it?
Yes.
It's not late.
Yeah.
I think I got a B list on my time this evening.
Play Steven Henderson. Pretty soon.
I got
That's my trick, Steven. Yeah, I got an A for
It's easy for you to get there. But I thought it said what you can't say it, no, you bet. That was so big. Not like that. It's like, you know, like you have to assess with an A. No.
Uh-oh, you can go still. Lean me in the back.
N20. What is that number? On the 20. What is that number?
343.
So what's your guess for the actual area? I don't know. Is that a 666? Okay. Yeah, maybe 81 2/3 or something. I don't know. So it really does seem like eventually maybe there'll be a way for us to get these values, you know, through analytical means without using a calculator. But I hope you see. Just remind me from yesterday. Why does LRAM? What's going on with LRAM and what's going on with RRAM in terms of over versus under estimates? Remind me which is which and why which is which here. Yeah.
LRAM is going under, RM over, because this is an increasing function.
Right. That's the full explanation. There's not much more to say than that. And then did anyone after yesterday think about why when MRAM over which is it here? Which does it seem to be here always? If the actual area we take to be 81 2/3, then it seems like which is it? It seems like it's always an underestimate by a hair as we get down here, just by a little. Did you figure out what's going on there, Albert?
Because when we put the thing in the middle, there's like an extra part on the left side,
Okay.
and then there's like an under part on the right side. But the left extra part doesn't quite fit into the right left under part. Sorry, that was really explained.
Great. Say it another way.
It's about concavity.
Okay. Say something more than just that
This
word.
one is underestimated because it's concave up.
Okay.
So that little left part Albert was talking about is going to be a little smaller than that part on the right.
Okay.
It's making like little almost triangles, and when it's concave down, little almost triangles bulge, so that the triangles at the base on the bottom are bigger, but if they go inwards, they're smaller.
Yeah. Now let me give you another explanation. Remember, this is a rectangle. We could rearrange the area in a helpful way. So let me draw a little picture here to help you see this. Let's see if we can, because I think it is a little hard to conceptualize. You're absolutely right. If it's concave up, then MRAM is an underestimate. But let me see if I can show you a picture of MRAM here. Where's MRAM? Here we go. All right, let's use this as our picture. Okay. So it does seem like, let's just look at one interval. I like thinking about triangles, and in fact, I think I can make what we've talked about just now more precise. If I take this midpoint, assume that's the middle of that segment, and I rearrange this and cut off this triangle and stick it up here. Now, if this really is the midpoint, then this is the same as this, and I'm like using a straight line here, so that this will be the same as this. These will be congruent triangles, right? This really will be the same area. This red trapezoid will have the same area as the blue rectangle. Do you agree? If I just like take the midpoint of the top of a rectangle, maybe you've never thought about this, and just rotate it up or down. That's all I'm doing. I'm like taking the midpoint and I'm rotating around that midpoint. I still get an area that's equal, don't I? Now, tell me again, which is this? This is an underestimate? This is MRAM for this concave up curve. This is an underestimate? Why? Now with my new picture. What kind of line is that to the curve? Oh, it's actually the tangent line, isn't it? And is the tangent line below the curve or above the curve if it's concave up? Well, it's below, isn't it? So I don't know if you saw that coming, but like maybe we have to actually invoke the use of the tangent line to talk about why MRAM for a concave up curve is an underestimate. Okay. Yeah, exactly. We have the opposite situation. If it's concave down, then we have this kind of thing happening, right? Excuse me. If it's concave down, we have the tangent line above the curve, don't we? So it cuts off a little more than it should have, right? So, all right, now I've got to go back to wherever we were. All right, you have this thing in front of you. Yeah, and I don't have anything else. Did you want to observe this anymore? We made an estimate for what we think the actual area is. We see it converging from below and from above. It's coming down, squeezing in on this. This is still an underestimate. It's not like the perfect thing in between necessarily. By the way, another method would be to average LRAM and RRAM, which notice that is not the same as this. Averaging left and right doesn't necessarily give you the middle, unless again it's something that's linear. Those aren't the same thing. So you might choose to think about that. I don't know. Be an interesting idea. So have you looked at this yet? Go ahead if you haven't. Engage in this one. And the next one, I have these on 2 slides here that we'll show you here. So go ahead and do these if you haven't started already. Check with your group members too. Notice like your program doesn't help you on graphs and on tables. You have to have the function for that. So
they use the table.
So don't think you can really use your calculator to help you too much here.
I'm lazy though.
Well, remember, since the subintervals are of equal size here, do you agree? You can quicken your work. If you're doing LRAM, what values are we using? We're using 30 and 36 and 40 as the heights, starting with 30. So you're using the left-hand endpoint for each of these intervals. So it'll be 30 times 2, right? And then 36 times 2. But we said earlier, if they're all equal, then we can maybe just use the distributive law to help us, right? I just mean, right? You can just factor out the 2 is all I'm saying. So I don't know what that comes out to, but that's the calculation I'm going to make. What's the setup for MRAM 3? Why am I doing MRAM 3? What's up with that? Can't I do MRAM 6? Why can't I do MRAM 6? Yeah, because I don't actually have the value for like a V of 1, right? And you can't just take the average of the 2. I really would want, if I'm doing MRAM 6, I'd have to have that value. It's not necessarily the average. But I can do MRAM 3, and those intervals will be from 0 to 4, and 4 to 8, and 8 to 12, right? What's the size of those intervals? What's the width then? 4? And again, we're doing MRAM, so what representative values will we use for each of those 3 rectangles for MRAM? What are they? 36, 48, and 60. Do you see them? 36, 48, and 60 are the height of the So for MRAM3, we're thinking about this interval, 0 to 4, this interval, 0 to 8, and 8 to 12, right? So we can give some approximations here. The first one comes out to 576 is the first one. 530.
Oh, the first one, yeah.
First one. What's the first one? Meters. All right. By the way, is this an under or over estimate for this one? LRAM. It is under. Now I want to caution you. It is under, but it's not simply because it looks like it's under. Okay. It's because it does look like it's increasing, but that's also not enough. It must say so in the problem. Right? If we're told that the velocity function is always increasing, okay, now I can make a conclusion. But it's not sufficient to just look at the table. You have no idea what happens in between 2 and 4. Who knows, right? Like, it could be crazy function. Like, who knows, right? I mean, we assume, maybe we make the assumption it's increasing, but that's an assumption. So, we do know it's increasing, though, because we were told. Okay, that's good. And then for B, what's the result you get there? 576? Confirm? Okay. Can we say whether that's an under or overestimate? We actually can't. There's nothing said about, like, we could say if it said it was positive velocity. That's what this helps us with. But we'd have to say it was excuse me, not positive velocity, increasing velocity. Here we'd have to say something about increasing, like, acceleration or something, right? Right? You have to, like, think about the second derivative or something. I don't know. Don't worry about it. Okay. Did you get these set up here? Let me get some people up here for this. Be careful. What do you have to be careful about here? Yeah, they're not equal intervals. Okay. And I think I highlighted this yesterday. For some reason, AP like loves unequal intervals. So don't. Which is good. It's good though. It dissuades you from like thinking like, oh, what's the formula for MRAM? It's always just rectangles, people. Okay. It's just don't ever even think about the formula. Don't even think about trying to solve the formula. Josh, do that LRAM 4 link there. And Peter is not here.
I'll do Peter because it's now.
Belinda, have you done one? Did you do one? Here. Why don't you do B, RM 4? And why isn't MRAM at all possible here? What's that? Yeah, I mean, it seems like, could we do MRAM 2, right? Like, we could do the kind of pull the same trick on the last one. But we don't have to. We could be like, oh, from 0 to 12, right? Like, we need the value of 6 for that. We don't have it. I think I'm right. So we can't, there's just no way to do MRAM of any kind here at all. It's just not possible.
I don't believe LRAM 4. It probably doesn't give us unequal intervals because the assumption is equal intervals.
Yeah. Now, actually, I had a fight. I might be wrong. I had a fight about that with Ms. Getz the other day. She was like, LRAM 4 means equal intervals. And I was like, oh, maybe. I don't know. Maybe it means equal intervals. She might be right. I don't know. But it's very clear what I mean here. So, yeah. But. Good. What are the units on those? Neither of our people gave us units. What are the units, though? Games, right? Thanks for adding that to the Josh's one too. All right. Well, I think that's all I have for you today, except to give you the homework. Just some more practice on this idea, thinking about these 3 methods of approximation, thinking about when they're over and under estimates, etc. You have to go where? Early?
I don't want to go. I want to
Like the day or two, maybe.
Yeah.
The homework is this package tonight. Okay? Not projecting, you got everyone get the homework?
Extra parts of the is the extra part counted?
Nick, I thought you wanted to be alone.
So with LLM increase. You want? Like this.
No, it's
Right. My house is lower and upper. It's the same left and then right.
Strong. Why is your target? Basically nothing to do
No, I want you to do your homework where it's at home. Or the period before.
I don't these account like literally like it's just
It makes you use 30%.
30. Oh my god.
and there's also a there's a it's like summons a random it summons a random which also the people who are running absolutely
I'm like, this is